Hi folks, we're going to take a look at number 9 from today's worksheet. So they're asking us to use the special angles to determine these trig ratios. So first thing is to figure out where this angle even lives. Now, one thing I want to mention, as soon as you see angles with pi and denominators of 3, 4, and 6, you should be thinking of using your special angles pi over 6, pi over 4, and pi over 3. Okay, so let's take a look at the Cartesian plane, and I want you to start thinking of these angles at the axes in terms of radians. So this would be the first step, I would say, to getting used to working with radians. So here, don't think of this as a 90-degree angle anymore. It's pi over 2. And pi, 3 pi over 2, 2 pi. So let's take a look at this first angle. Well, it's 2/3 pi. Now 2/3 is bigger than a half, so it's got to be bigger than this angle here. But 2/3 is less than 1, so it would be less than that angle there. So it means it has to be in the second quadrant. All right? So question is, what are we going to be using? So when I see here a 3, what I'm going to be thinking of is working in thirds. So if I draw a diagram here, so from 0 to pi, what I'm going to do is I'm going to break this up into 3 parts. So this is going to be pi over 3. Okay, then I'm going to have 2 pi over 3. And then, of course, once I get to this here, I'm going to get to pi, which is 3 pi over 3. So the angle I'm working with is this one here, 2 pi over 3. But what I'm going to do is I'm going to use what I know about my special angle, and I'm going to use the related acute angle. So in this case here, if this is 2 pi over 3, and going all the way to that other side is 3 pi over 3, it means my related acute angle is pi over 3. So that means I'm going to be working with this special angle, or special triangle. So now we're going to use the information on this special triangle and insert it onto this diagram here. Okay, so my triangle is going to be 1, 2, root 3. Okay, however, remember that we're not actually using the triangle to determine the trig ratios. We're using the x and y values and r value associated with this point on the terminal arm. So here I'm not actually working with 1 because the x value is going to be negative. So I'm just going to input this as negative 1. Okay, the y value is still positive, so it still remains root 3. And the r value is just the distance to the origin, so that still remains 2. So now, once I have this information on the special triangle, I can just read off the answer. So in this case here, it's because it's sine, it's going to be root 3 over 2, the opposite over hypotenuse. Okay? Whereas if I was looking for cosine, adjacent over hypotenuse, negative 1 over 2. Or if I was looking for the tangent, it would just be, y over x, or opposite over adjacent, root 3 over negative 1. Okay, so once I establish which special triangle I'm working with, and I establish the signs of the x and y values, I can just read the answer off. Okay, so let's take a look at this one here. Now, 5 pi over 4, well, 5 over 4 is greater than 1, but not too much bigger than 1. So I would expect this angle to be somewhere in the third quadrant. Okay, so let's draw it here, except now I'm not going to be thinking of breaking things up into 3s. I'm going to break things up into 4s. So I'm going to break pi up into 4s. So this is 1 pi over 4. This is 2 pi over 4, like pi over 2. 3 pi over 4. 4 pi over 4. So I need just one more pi over 4 to get the angle that I'm looking for. So this is 5 pi over 4. This is the actual angle that I'm determining the trig ratio for. But I want to set up my special triangle. So I take this to the x-axis. So if this to the negative x-axis was 4 pi over 4, I just had to add an extra pi over 4. So my special triangle is going to be the special triangle for pi over 4. Okay. So now I'll input my x, y, and r values. My x and y values, well, they're both negative. So this is not going to be 1. It's going to be negative 1. The y value is going to be negative 1. And then the r value is going to be my root 2 from my special triangle. So now I can just read the answer off the diagram. Okay, so since I'm looking for cos, it's going to be x over r, so it's just going to be equal to negative 1 over root 2. Now, by the way, it makes sense that the answer is negative, since, of course, if we use our old cast rule, we know that cosine is going to be negative in this quadrant here. Okay, let's do this last one here. Let's again start by drawing the diagram. Now here, I could break apart pi into sixes, okay, but I'm going to notice here that 11 pi over 6 is very close to 12 pi over 6. 12 pi over 6 would just be 2 pi. So imagine if I were to go all the way around to 12 pi over 6. What's 11 pi over 6 going to be? It's going to be just 1 pi over 6 less than that. So my angle, 11 pi over 6, will look like this. And so the related acute angle would just be pi over 6. Okay, and now I can create my special triangle. Let's look at my pi over 6 special triangle. Well, this is going to be 1, but since it's on the negative side, it's going to be negative 1. Okay, 2 and root 3, the x value will remain positive. So now I can just read my answer off the diagram. Since it's tan, it's y over x, so negative 1 over root 3. Okay? And this is how I suggest you solve these trig ratios when you're working with a special angle. And what happens is you get much, much quicker at drawing these diagrams. You don't have to think about them so much. So the idea here is, first of all, identify which triangle you're going to be associating it to, and you're going to know that by looking at the denominator. Okay, use that denominator to split up your Cartesian plane appropriately to figure out where your angle is going to be. And then from there, once you associate your special triangle, you just have to get the correct signs on the x and y values. Okay, that's it for this one.